Hi, Tarquin Rao from Liquid Instruments, and today I thought I'd show you a couple of things about our digital filter blocks application. So as you can see, I've got a rather weird setup here. I've got two Mokus, and the one on the left I'm going to set up to use the digital filter box, and the one on the right I'm going to set up to use the Bode analyzer, or as we now call it, the frequency response analyzer. I still call it the Bode analyzer because I can't say the word frequency, but anyway. What I'm going to do is generate a signal from this device, pass it through the filter box, and you'll be able to see the filter as I sweep the frequency using the frequency response analyzer. So let me load up the two instruments. Digital filter box, go and go. So there we have the two instruments. On the right, the frequency response analyzer, and on the left, the digital filter box. So the digital filter box offers you this diagram. You have two signals coming in here on channel 1 and here on channel 2. Then they go to this crazy matrix thing, which I'll explain in a moment. And then you have the output to channel 1, which is off there, and the output to channel 2, which is off there. So first, let's look at this matrix. This is actually really useful. The top row defines what combination of the two signals goes into the channel 1 output. So this is saying take 1 times the input from channel 1 and 0 times the input from channel 2 and put it through this chain of events. If I do that, and make that 2, okay, now it would say mix 1 times the input of channel 1 and 2 times the inputs on channel 2 and put that combined signal through into the green channel. So that's a really useful mixing feature. I've reset it to 0, so the signal comes in. You can then put an offset and a gain on the input. Then there's a probe point, which I'll show you in a while. Then you can select your filter. So the filter box offers a range. So if I go here, this is a low pass filter. It lets most of the signal through up below a certain frequency, in this case 100 kilohertz, and then it attenuates it very quickly. You can have a high pass filter, which does the opposite. You can have a band pass filter, which just lets a band of stuff through. You can have a band stop filter, which lets most of it through except a gap, and then you have the option to build your own. Let's today use a band pass filter. So it attenuates the low end of the signal and the higher end of the signal. At this stage, it lets through signal roughly between 1 kilohertz and 100 kilohertz. So on the Bode analyzer side, the first thing I'll do is turn off channel 2, and I want to set my swept sine so that it goes, say, starts up around the 150 kilohertz, 150 kilohertz, and it goes down to, say, 20 kilohertz. 20 kilohertz? No, lower than that. Say 200 hertz. So first of all, we need to send this signal out. So I'm going to turn off channel 2, turn on channel 1, and we should be set. So now it's sending a signal out. But here you can see we're between 1 kilohertz and 100 kilohertz. But I'm not sending anything out. If I turn this on, now there we have the signal. And if I pinch this, you can see how, as I drag cursors across, this is about 1 kilohertz, and this is about 100 kilohertz. So now if I go to my digital filter box and I change that to, say, be 10 kilohertz, 11 kilohertz, or you can actually tap on that number and key in the precise amount that you want. When I press done, that changes the signal. So now when I run this, we should see, as we do, that the Bode analyzer or the frequency response analyzer is now showing the new characteristics of the filter.